Hello everybody, welcome to Lab Hours. Today I am going to give you the Stata 1 lecture that I wrote for Econ 378, Statistics for Economists here at BYU. That is to say it's going to be the first of the two lectures that I wrote. The first one is a lot more heavy-handed. It's a lot more like I'm going to kind of hold your hand through the teaching notes, and I'm also going to have the teaching notes that I'll refer to every once in a while. Those will also be linked along with any other files, folders that you will need in the description of the video and also at tmorg.org. Wherever this ends up. All of my resources are going to be there on my GitHub or in places you'll be able to get to by going to tmorg.org. This lecture was designed primarily as an introduction to Stata, clearly, and to its four basic windows, but it's also designed in a way that we want to get the students to get out of Excel and into Stata when they start doing their data projects and stuff like that. And so it also serves as a nice, helpful introduction to people who have never seen Stata before. Maybe they're coming from R or SAS, and in which case this might feel a little bit slow to them, but it should help anybody who wants to get a good handle on Stata to just sort of get the basic gist of it starting up pretty soon. So here in Chrome, I have pulled up my lecture notes. I will refer to them every once in a while. Hopefully you won't need to. But I'm going to just refer to them for the order of the things because I kind of did this off the cuff when I did it the first time. So we're just going to go from there. But the way that I started the lecture when I first gave it is I told the story, and this is particular to me, but you can also, you don't have to tell this particular story. I told the story of when I was in a freshman level writing course right after taking my Statistics for Economists class, and I had not learned Stata at the time. At the time, the curriculum only taught us Excel, and so I wanted to do a project about county-level fair market rents and county-level poverty rates, wanted to see if they were kind of close to each other, and I wrote my symposium paper. That's one of the papers for the class on that. I have some allergies this season, so you're going to have to pardon me a little bit if I've got to sneeze, or it'll just torture me. That's okay. Take that out in post. Just kidding, I don't have time for post. But basically the idea is I just pull up these absolutely massive county level data sets that are here in these Google Sheets that I, again, have linked in the teaching notes, and the link will also probably be in the description. If not, it is just at the end of the teaching notes, so that won't be too bad. And I show them, this is like the final sheet that I got that was clean, and you can see I had to use like conditional formatting to like, while I was cleaning it to see if I had matches and stuff. And then I just kind of show them the raw files that I pulled those from. Anybody who's done big data work will be familiar with the fact that these data sets can get kind of long, and that county data sets are even not that big, is the crazy thing. So I show them these, you know, and I just go, look at this, it's crazy, and I was doing this in Excel. And this lecture comes right after we give them their first Excel lecture, just for the people who maybe have never done anything with any spreadsheet software ever. And so I usually get to go like this and just be like, can you imagine how awful that would be? And they're just like, yeah, it'd be awful. I mean, I've done it once, but I imagine that would be the response most of the time. And so I just say, because we have this problem, we've developed tools like Stata, R, SAS, fill it in with whatever you'd like. But in our course, we do teach Stata. So let's see. That covers everything through Excel is not the answer, yada, yada. There's got to be a better way, right? And so we're going to open Stata, but before we open Stata, in this folder, I am going to download this example.dta file. In the lecture notes, I say to have this downloaded to the desktop or wherever you'd like to have it downloaded to prior to beginning the lecture. I still think that's a good idea, personally, but we will just make sure this is there. It's already here. Perfect. So I've got this file on my desktop. Excellent. So we are going to move into the actual Stata lecture now, and this is going to go a little bit quick because this is a video. Like ideally, this is probably written to be about an hour 15. I'm going to try to cruise through it a little bit quicker than that, but no promises. So we're going to open Stata, and we're going to start. This is the general format of the lecture. We're going to start by displaying what the command window is and the important things about that. We're going to come down and then talk about the browse window. Then we're going to talk about the help files, and then we're going to talk about the do editor. And that is the four basic windows of Stata. Basically, if they can get a handle on these four windows and what they do, they can get a handle on pretty much the whole program. So let's do that. We're going to open Stata, describe the general layout of the command window. We're not going to talk about the CD line in the bottom left. I'm just going to teach you as if you were here in the room. So let's figure this out. And I actually usually have a little note in front of me with like a little outline. So I'm actually going to grab that really quick and pull it up so that I don't have to keep pulling this up for you guys, because of course this is an example lecture and I want you to be able to see the screen as if I were just simply giving this lecture. So apologies for not having that pulled up already, but it will be pretty quick because I've got it pulled up right here. So let's go ahead, and now that we've got this example file downloaded, everything's kind of taken care of. You get the gist of what's going to happen here. You've heard the story. Feel free to adjust that however you'd like when you give this teaching, but we are going to open up Stata now. And what a beaut. We're going to start by talking about the command window. It's going to ask if it wants to update, potentially. Maybe it won't. That's great. So we're going to talk about Stata, and we're going to talk about, this is the command window. This is like the main opening window, the way that Stata greets you when you open it up and ask it to teach you, to help you do some number work, help you crunch some numbers, right? So I point out where you type commands, and normally it will actually pull out a little bit like, I've done a lot of work, so obviously I've moved the dimensions on this. It'll usually look a little bit more like this. And I do the basic things. I point out what is the command line. We can run commands here and just say, hey. Obviously the command hey doesn't exist in Stata, but this is where we type stuff and where we tell Stata what to do. Stata likes to keep a little log of what we do over here, and you'll notice if I click a command, it will pop up in the command window. If I click it from the history, which is really nice, it's the history, of course, it says history. That will be useful later, so we're just going to keep that in mind. Over here, Stata tells us what kind of variables it has loaded in. We haven't loaded in a data set, so that is currently empty. There are no items to show. Stata never lies to you. It's very nice like that. I don't usually gender Stata, but what can you do? So the first thing we're going to do, I will point out to the students generally while giving that Excel story that Excel formats include comma-separated values or the actual XLS file format, and I will point out to them that this was a DTA file, which is like the Stata equivalent of the .xlsx, right? This is the Stata file. And so the nice thing is I can just tell Stata, hey, Stata, will you please use example.dta? And I'll say, you don't have to do the DTA, but I'll do it for now. And I point out, hey, file example.dta not found. What the heck does that mean? Well, the interesting thing is that Stata is very particular in that it never wants to do anything you don't actually want it to do. So you have to be kind of specific sometimes. And I do realize that this lecture is going to sound a little bit like lower level. This is for people who, in my mind, have no experience coding or doing anything similar prior to the lecture. So this is going to talk down a little bit and kind of bring the concept of coding and stuff like that down a little bit lower preliminarily at a very basic level, right? So I'm going to say, hey, Stata, will you please use example.dta? But I'm like, hey, it's right here. I can see it. It's on my desktop. Why doesn't Stata use it? And this is where I introduce the idea of directories and the directory line down here in the bottom left. And the nice thing is if I'm projecting this up on the screen, I can actually walk over and like point to it, which is really nice. But basically what we're going to do is we're going to say Stata is a lot like an assistant in that but it's very particular. And the way that Stata interacts with your computer is it basically treats your computer as a gigantic filing cabinet with a bunch of different drawers. And Stata will only ever look in one drawer at a time because it doesn't want to pull a bunch of different files by mistake. And so we have to tell Stata what folder it's looking in. But first of all, to change the file drawer that it's looking in, we need to know which drawer it's looking in right now. And that's what I point out down here in the bottom left. It is looking at users Morgantoe documents. So I didn't mean to do that. That's my bad. I'll maybe pull up the file explorer. Let me just check to make sure my videos are still good. Yep, we're good. So I'll pull up the file explorer and I'll point out, hey, this is the documents folder right here. And the path, you can't really pull it up quite like this, but this is the drawer in the filing cabinet that Stata is currently looking in. And of course, there is no example.dta file in here. So how is Stata going to find it? Well, I will suggest to them that maybe we need to change the directory. And the nice thing about that is that the command for that is very simple. And when I write this command, we're still just going to talk about this as if, they know what a command is, but we'll get there, don't worry. So I'm going to say cd, and then I'm just going to say, I bet if I switch this from Morgantoe documents to Morgantoe desktop, it will probably work. That will be my guess, so we'll see. And in fact, you could throw in like a dir, like a directory, to just say, oh, look, there's nothing in there that it's actually called example.dta. That one's pretty helpful. You can pull up the dir, and I think if you type directory, no, it's just dir. That's fine. So what we'll do is we will type cd or change directory. We'll say stata, will you please change your directory to C drive, users, Morgantoe, desktop. And then we'll point out, hey, look, now it's looking in the right folder, we think, but we want to make sure, so we'll maybe type dir, and look, Stata sees an example.dta file, which means I can tell it to use the file, and we're good to go. Now I'll point out that we have variables loaded into the data, super cool, and we get to move on from there. Use a file, correct, click the command. I'll also mention that we want to generally avoid these buttons other than like the save button and the browse button, or like the do editor and like the browse button, just while we're doing this, because like I would point out that we could just open the data set and go find it, but it's kind of prohibitive to learning the basics, because these easy commands like CDs really help sort of set the foundation for understanding what's going on with Stata. So now that we've gotten there and we've actually loaded in a data set, I'm going to take the command window, I'm going to put it up here, now that they're a little bit more familiar with it, and now I'm going to open up the browse window with a browse command, or BR, and I will point out to them, I'll just kind of even it up over here. We see, now we're in the browse window, so we're in phase 2 of this lecture at this point. I point out we have our list of variables here, and here is our, the actual data. And maybe I'll come over here and I'll go to font and just blow it up a little bit so that it's a little easier to see, depending on, how this is going. Depending on who I'm projecting to, how big it is, how far away the students are, you do you, right? But I basically come out and point out, hey, this is basically just a glorified, dumbed down Excel, right? Because this is a spreadsheet. We have the number column and the string column, observations 1 to 17. This is where we start to talk about variables and observations. And I'll also point out edit mode. Like, you can click this button up here and actually type something like, I'll turn this into 93. Wow. And you'll notice I'll point out to them that it actually ran a command in order to do that, which is pretty cool. And we'll talk about that later. But basically, this is like a really dumbed down Excel. You don't want to actually go in and do any data editing in here, but it is helpful to understand how to look at the browse window so that we can understand kind of what the data is that we're playing with, what it looks like, how we can find potential problems with it, and so on and so forth. So we're going to talk about the difference between variables and observations. That's easy. Variables in a column, observations in a row. So variable number, the observation with number 1 has a string value of 2. Great stuff. Not really meaningful right now, but just nice to keep in mind. Okay, so then maybe we talk about what the missing value is. I point out that, and this is also where we have to start talking about, numbers and strings, right? And so I'll talk about and I'll say, hey, did you guys notice that this number category is black and the string category is red? What could be the difference here? Well, and then I point out there's like letters in this one. This space is just blank. This one has periods. And so we get to talk about the difference between numbers and strings, numeric values and string values. We also get to talk about the missing value in both of those formats, right? So I'll say to the students, now look, in this number category, when Stata presents values in black in the browse window, that means Stata recognizes that those are numbers and it knows how to add them. So if you said, hey, Stata, what's the value of observation 3 in the number variable plus the observation of the number 4 in the number variable, it would tell you, oh, those are numbers. I know that that's 48 plus 5, and I know that that's 53, and it would tell you 53 because it knows that these are numbers. But when you come over to the string variable, if you were to ask it to add observation 3 to observation 4 in the string category, obviously it can't do that because there's a letter in there, right? And we know that and we can see it. But what if I asked it to just add observation 1 and observation 2? I can see that that's 2 plus 74, which is 76, right? But Stata doesn't know. When Stata looks at a string variable that's in red, what Stata sees is just characters. It says, I don't know what this observation number 3 is, but I know that there is a 9 followed by a 2. I don't know what to do with it, but I know that it's there and I will show it to you, right? So that's what the red means. You'll also notice that we keep leading zeros in the red, so this is nice sometimes for like identifying variables like ID numbers or like zip codes and stuff like that that might start with 0. The one thing I also point out is that the missing value for numeric variables is a period. So if this space is blank, right, or if we took this space and turned it into a numeric variable, that would turn into a period. The period in Stata is coded as the biggest possible number. So like basically if I wanted to get rid of all the missing variables, I would use a command that we'll talk about later, and I would say Stata, get rid of all the ones that are bigger than like 62. And if they're bigger than 62, get rid of them, and Stata would get rid of all of these dots because it's coded them as just absolutely massive, massive numbers, okay? But for all intents and purposes, that is how Stata marks that things are missing. In numeric variables, in string variables, it just leaves it as blank. Super nice. Now that we've gotten through basically what is in the browse window, this is about the use of the browse window, is to see the format of your data, what it looks like, general patterns, things that are missing, but that's about where the browse window's usefulness comes to an end, at least at the basic level. So now we get to introduce a third window, which is going to be the help file, right? Because I'm thinking, well, basically in the browse window, I say, what if I want to take this string variable, and maybe just to avoid confusion, I'll say rename string yeet, right? Just for funsies, right? And maybe what I want to do, first of all, I'm showing that cool command and how, and I can show a couple of those commands to see how what I run in the command window translates to the browse window. Like it's just doing these massive things, which is super cool. You can use fun things like rename. Those ones are easy to show, and you can immediately see that things change, right? But the thing that I want to do now is I want to use some kind of command that will take this string variable in red and turn it black. I want Stata to recognize the numbers that are there, okay? And so I'm going to use a command called toString. It looks like this, and I'm going to introduce this before I introduce the help file. I'm just going to suggest to the students there is a command that does this, and we'll talk about how to find particular commands to do things later. So I say toString, and I want to use this toString command that I heard about from somewhere, but I actually don't know how to like do it. So maybe I'll just say, hey Stata, why don't you just turn the variable yeet to a string, toString yeet, go. And it says must specify either generate or replace option, and I say, what in the world could that possibly mean? And this is where we get to introduce this third window in Stata called the help files or the help windows, right? So I'm going to suggest to the students, right, that there is this wonderful, this is probably one of the greatest strengths of Stata, are these help menu files. So I know the command toString, and so if I just take help toString, Stata will pull up this awesome manual that will tell me exactly how to use the toString command. And you'll say, well, now hold on, Professor Morgan, or just like Tommy, right? This pulled up help dstring, and then I'll say, no, look. So we've got the dstring here, and we've got the toString here. And this looks like a bunch of gibberish right now, but we're going to talk about exactly what it means right now. We are now in the help window, and I'm just going to place it right here to look kind of cute. Just right there, somewhere nice and easy. Okay? So I will bring up the help menu, and now we move into the third phase of the lecture, right? I bring up, hey, look at that. So when I tried to run this toString command, and I wanted to turn yeet into oh, well, yeet is already a string. What am I talking about? Replace every instance of toString here, or yeet with number, or just one of the ones that will make it work. Because clearly yeet is already a toString. It's already a string. I hope that you can correct that or understand. But basically, even if I were to do this in front of the students, I would go, well, obviously, yeet is already a string. Hopefully one of them would raise their hands and tell me yeet is already a string, right? But I wouldn't count on that. So if I caught this mistake for myself, I would say, actually, you guys, it's already a string, so of course it didn't work. But what if I tried to dstring yeet, and it still gives me the same thing, right? It still gives me must specify either generate or replace. Well, what if I just try toString? Maybe it's just something about yeet. What if I try two-string number. And it's still, Stata is still telling me the same thing. It says, look, I can't do this without a generate or replace option. I go, what the heck is a generate or replace option? And then we get to pull up the idea of the syntax of a Stata command, which is command for most commands. It's the command, the thing you want to do the command on, comma, options. So it's the command, the thing you want to run the command on, comma, options. That is the most basic form of a Stata command. And I'll maybe go back and point out, hey, I never actually used any options in these commands, but I will later, and I'll show them maybe like options on use or something, but later. Part of Stata 2, right? So I want to know how I can actually take this yeet variable and turn it into a numeric variable, because I need Stata to do some math with all these numbers, right? So I'm going to use dstring, not toString. All right, so dstring varlist, and I say, what do we think that varlist could be? And then maybe if they answer, if they want to raise their hands, maybe someone will have experience with coding in their answer, and they'll answer. If you don't think any of your students will have that, maybe you could just suggest, hey, variables, maybe dstring is the list of variables that we want to turn into numbers, right? And so we'll say, okay, and I'll point out, though, that we've already tried that. We tried dstring and then the list of variables that we wanted to dstring, which was yeet. It was just one variable. We could put multiple of them there, but we only want one. There's only one that is a string to dstring, right? So then it says I must specify either a generate or a replace option. And then here's where I say command, thing you want to do the command on, comma, options. That is the Stata syntax, and we want to get that really clear, right? This comma here tells Stata, okay, I'm done giving you the command and the thing I want you to do the command on. Now I'm going to tell you how to do it. That's what the comma does. Every command is only ever going to have one comma, unless you're doing a bunch of graph stuff that we'll get into later, later in their Stata career. For now, every command has one comma, and all the options come after. Now, I'll also point out we have this curly bracket here around generate new var list or replace. And then we have the square brackets here around dstring options. Well, one thing I know about dstring is that I must specify either a generate or replace option. And if they haven't gotten it yet, generate or replace is a necessary option, which we know because of these curly brackets. These curly brackets in the help menu tell me you have to include one version of these options. And we'll remind them, that this bar right here in the Stata syntax, and by remind them, I mean tell them if they've never known this before, but this little bar right here in Stata means or. And so it says I must specify either generate or replace. This says, in curly brackets, I must specify either generate or replace. Super cool. Then I'll point out, okay, generate new var list, what does that mean? And then the nice thing is we get to come down and I say, okay, I have this general line of syntax. This is how I actually have to write the code. But how do I know what these options actually do? Well, I just scroll down a little bit, right? dstring options, description. So the generate and the replace have stars, which we see. Either generate new var list or replace is required. And by the way, I'm going to spend a lot of time on these help files because I think that if you can teach the students the very basics of command, browse, and do files and just help them get really good at reading the help files, that is going to save you a lot of work and a lot of redundancy in the things that you're trying to teach, because they will figure out, they can just Google what the command might be, and if it looks like in the help file that's what they want to do, then they can just use the syntax and do it. Hopefully it will save a lot of time for the students and for you and for your TAs. And I think it just makes them better programmers overall, because so much of programming is looking up on the internet or in help files or manuals how to do something you don't want to do but that you know you want to do, right? So that's why we're going to spend so much time here on the help file. But basically, the general idea is, look, generate new var list says generate new var1 ... new var k for each variable in var list. So if I were to write dstring yeet, comma, for the option, generate, parentheses, let's call it yeet num for yeet in the numeric form. What this command will do, according to this right here, this help file, it will take the variable yeet and it will destring it, which means it's going to take all of the numeric variables and turn them to numbers, and it's going to take all the non-numeric variables and try to turn them into numbers. It's going to be great. And then what it's going to do is, instead of just getting rid of this column and trying to take all of those values and just replace them with numbers, it's actually just going to come to this column right here, this third column, and create a new variable called yeet num with what it does with this yeet variable. So let's go ahead and run it. And what do we get? Well, it's not quite, my view window here isn't quite long enough, but if I run it with a wide enough window, it says yeet contains non-numeric characters, no generate. And I say, well, I know that yeet contains non-numeric characters like spaces, blanks, the word, a nice link, right? And so maybe it's just because it has all of those weird characters that dstring can't actually do anything. So maybe I'll just say dstring yeet replace. Maybe I'm okay if we lose this really, really cool link right here and all this other non-numeric stuff, if it'll just give me the numbers. That would be really nice. So maybe I'll say dstring yeet replace, and it gives me the exact same thing. Well, the trouble is with Stata, it never wants to kill any of your data. It never wants to lose anything that was important to you unless you tell it it has to, right? So one of the interesting problems that you'll have, by the way, if you did not know what to do, and this would be to the students, right? If you did not know what to do from this point, what I would recommend you do is actually take this line right here, or maybe the one that isn't specific to your variable, right? The thing that says contains non-numeric characters, no replace. Take that, copy it, and bring it to Google. And if I just Control V right here, contains non-numeric characters, no replace, and then maybe I add Stata to the end just for good measure, right? dstring returns contain non-numeric characters, no replace. This is the statalist.org forum. They will probably have an answer for you. Look at that. I tried to dstring two variables. One of them is the column, yada, 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 yada. And here are some answers. You can do a couple different things. You could use encode, generate label, yada, yada. This is for their specific problem. But one thing that they could potentially find, and they actually wouldn't do this because this is a real data problem and the solution that they want to find isn't actually here. But if we don't care about losing the non-numeric characters, you could maybe throw that into the Google search or something like that, right? Or if we just read down here to this option right here called force, it says convert non-numeric strings to missing values. Maybe something I could do in this help file is look at non-numeric, right? That was not the correct search thing. I actually have to come here, hit Control F or Command F on Mac, and on the page, find non-numeric. Okay, look at this. The first thing that comes up, either generate or replace must be specified with either option. If any string variable contains non-numeric characters not specified with ignore, then no corresponding variable will be generated, nor will that variable be replaced unless force is specified. So now I've got two options in bold that I could use to potentially get around this problem. So I take a look at them, and maybe I can come back to this quick one really quick. It's really nice. In the dstring options, I have this ignore option. It says remove specified non-numeric characters as characters or bytes. What that will do is, so like if I wanted to turn this value number 4 from N95 into just 95, I could run a dstring yeet replace with ignore capital N. The trouble is I have a lot of non-numeric characters. This could be super helpful for like this N95 case or like this comma case with the 525600, right? I could run an ignore comma, and that would be super helpful for me. However, I have like full words and stuff in here. So for me, the force option, which converts non-numeric strings to missing values, is actually probably going to be much more helpful. So let's go back to our generate yeet num command by clicking it in the history, right? Let's do dstring yeet, generate yeet num, and then again, I'm just going to come back to the syntax to make sure that I'm writing this correctly. Dstring space, the var list, space, comma. The space in between the comma isn't actually necessary, but space, either generate or replace. I've picked generate, and then space, another option, dstring underscore options, dstring underscore options. One of those is force, so I'm going to hit space and do force. Now, just want to pull up the browse window. This should work, and it does. This is a super fun moment in the lecture because we get to say, look, it works. Stata did exactly what we want. It took everything that had non-numeric characters, which is like the capital N or the space in hey hey or the period, the string value of the period in teamorg.org, and turned them into missing values. So now Stata's just like, there is no number there, I will not add it. Great stuff. And then maybe we can just do, just for demonstration purposes, let's do a toString on number. Let's turn number into a string. So I do toString number, and let's just come back to the help file, right? toString, the variables I want to turn into strings, comma, either generate or replace, and then the toString options. The nice thing is I probably won't need any toString options because this is already in a number form, right? And I just want to turn it into a string. So let's toString number, and let's just replace it, right? I'm going to unhighlight it over here so that you can actually see what's going to happen when I run this command. Boom, it just turns red. Now the interesting thing is that all the missing values also have turned red, which is really weird. Maybe I just want to do the following. What if I replace, this is another command, I'm just going to throw it out there. What if I want to replace every single missing value in the variable number with just blank spaces like this one over here in yeet? Well, this syntax I would look up in the help file, and I would recommend that you look it up in the help file when you teach this class. Close out of this one and do a quick help replace, you know, and go over the syntax, yada yada, because it's with generate, replace, set type, all that stuff. You basically can just talk about, generate we'll talk about more specifically in Stata 2, but replace is a pretty easy one to throw in here, which is really nice. So maybe you can just like do replace old var equals x, although if you don't want to talk about equals expression, because I think that also, no, this actually comes here, right? And the interesting thing is I usually do this with drop. So actually let's do this with drop and keep. So instead of doing replace, let's say I don't care about any of these observations if number is missing. So first, let me just dstring number really quick with a replace option just to really drive it home, and it says all characters numeric replaced as byte, 3 missing values generated because it took those periods and turned them into missing values. Good stuff. That is the one non-numeric character that Stata can deal with, which is super nice. So let's talk about, I only want to keep the observations that have a value that isn't missing in the variable number, okay? So let's talk about that. Let's talk about drop and keep. This one's a really nice one. I like because they also show up on the same help file, which is probably why I wanted to do this, right? Because it lets you do drop var list, drop if, drop in, super nice. And then you also get to talk about keep. So this looks pretty bare bones when we open up the help file. However, when we come down, we get a detailed explanation of exactly what these do. Drop eliminates variables or observations from the data in memory. Keep works the same way as drop, except that you specify the variables or observations to be kept rather than to be dropped, so on and so forth. It's not reversible, which is why we're going to talk about do files after this. It's going to be super nice. But let's come over here. We have the my bad. We have the syntax for drop and keep here, and now we get to also introduce the if logical expression in the in range, which is super nice. So let's just show that really quick. Let me do really quick just a drop variable. I don't need yeet num, that was just fun one. So let's run drop yeet num, because again, this is just drop var list. Drop the ones that you don't want. Okay, boom, it's gone. Now, what if I really quick rerun my dstring yeet generate yeet num command that worked before? What if I, instead of doing drop yeet num, I instead said, how about I keep number yeet? Will that do the same thing, students? And hopefully they will say yes. And then we do it and we see it did the same thing. Great stuff. So that's just dropping variables, keeping variables. They haven't talked about dropping or keeping observations yet, and this is another time to just drive home, hey, these rows are observations, the columns are variables. That's just a nice thing you get used to thinking about, right? So let's run this command, drop if x. What the heck is exp? Well, I could click it if exp. That's the nice thing about the help files too, is if it's something that could confuse you, it's probably in blue text, and if you click it, it will pull up a helpful thing. Command if exp is the syntax. EXP in the syntax diagram means an expression, a logical expression, a thing that can be true or false for a given observation, such as age is greater than 21, right? If I gave Stata the expression age greater than 21 or number less than 10, right? Stata will go through all of the observations in number, row by row, and it will say, in column 1, that statement is true. The expression number less than 10 is true. 2, true. 3, false. 4, true. 5, false. And so on and so forth down the rows, right? Great stuff. So let's go back. Drop if expression. Well, what if I want to drop if number is missing? If number is equal to the missing value. Easy peasy, right? Wrong. Here's the trouble. This is where you get to distinguish between the single and the double equals. It's just one of those fun, funky, annoying little things that people have to get used to when they start to use programs like this, but just anybody who has any basic coding experience is going to know this already with the double equal sign. But you basically get to do drop if number is defined as the missing value, as opposed to is defined as, or like is strictly equal to, or whatever you need to say that you think might help them remember, hey, it's not just is equal to. In this case, we're actually talking about like that is exactly what is in the cell, right? So now when we run that, it drops, fully deletes the 3 observations that were missing number, which is super cool. We love that. Now let's say even further, I actually look at this list and I realize I actually only want to keep observations 4 to 14, right? I just noticed there's some kind of error in observations 1, 2, and 3. So I would do drop in range. And again, if I don't know what this means, I click it because it's in blue. In range. Command in range, where range is either a number slash another number, a number slash the letter L, or F slash a number. In at the end of a command means that the command is to use only the observation specified, and it's allowed with most Stata commands. And then it gives you a nice little example of stuff where F and L and L refer to first and last observations. So let's say I wanted to keep only the first 10. I could do keep price or keep number in 1/10. That's how it does like through, like 1 to 10 is 1/10. So let's come back. Drop in range. What if I want to drop in 1 to 3? Boom, they're gone. Excellent stuff. And then maybe I'll scroll back up here and I'll notice, do you guys notice that when we edited things in the browse window way back then, it replaced string to have a certain variable in observation line 3? When we typed that, that was the in thing, and it's a nice little fun little callback. I don't actually know how long this is, but we're almost done, I promise. Keep, drop, you play with a bunch of stuff like that, and then you can go d-string, 2-string, d-string, 2-string, drop, keep. But basically, you'll get to the point where you've shown a bunch of stuff, you're playing with the data, but now you're like, once you have had your fill of that and have explained it all clearly enough, basically what you want to do is come to the point where you realize you have deleted a lot of your data. And maybe that wasn't the best idea. You know, maybe you actually accidentally said drop in 10 to 11, right? Oh no, I meant to type, well actually that one's not super helpful. Maybe I wanted to keep if number is greater than, I don't know, 10. Maybe I typed keep if number is greater than 10. And then I go, oh man, I meant to type keep if number is less than 10. Oh man, what am I gonna do? Fear not, that's okay. I will point out at this point that normally in programs you can do like an edit menu and click an undo button, or maybe there will be one up here, or you can hit like Control or Command Z for undo in a lot of programs, but Stata does not have an undo button. And now we are finally out of the help menu section, and we are going to talk about the do file editing section, or the do file section. So I'll type do edit, or I'll click this button up here to start, or not the data editor, but the do file editor, right? Do edit, and that will bring up this file right here. And at this point, basically, I kind of have to split the windows into like these 3 columns, because if there is any like difference in elevation among the students who are in the back might, or if there is no difference in elevation, like if you're just in like a flat computer lab, the students in the back may not be able to see the bottom of the screen. So just keep that in mind and adjust accordingly, of course. But so basically I just come over here, right? Here's the browse window, it's still over here. Here's my do file. And what I do is I explain the do file is basically the undo button. And I will show them the idea that I can take these commands that I used in the past that worked, right? Let me take this change directory one, for example. I'll copy it and I'll paste it over into here. And when, oh, pardon, sorry. Throat's getting a little. So the first thing I'll say is, hey, look, here's this command. And it's in this file now. Do file. What does that imply about what the file will do? Well, the do file will run any code that you put in it, as if you were just typing each line one by one into the command window. So if I run this file, here's the play button, the execute button, or the do button. I play that. Over here in my command window, it says, look, I'm changing my directory to this directory. Now, of course, we had already done that, so maybe I'll, delete the P and show it's unable to change to that because there is no file, or there is no drawer in the filing cabinet called desktop, right? But now if I run this, the command runs just fine. And then I'll say, and here's where I will stress commenting code. Well, actually, what I'll do, I won't stress that yet. So first I'll just write a bunch of lines in here, the ones that worked, right? Like the use example.dta, Control C, and then I'll go back and get the, I'll go back and get the rename command. That one was an important one that we did. And then we'll go get, I did actually really want, basically just get a couple commands. I wanted to drop in 1 to 3, right? And so I'll copy paste that one in. And then I'll take this 32 here and I'll copy it, the one that I thought was an error, and then I'll actually switch it to just be to be less than 10, like I meant to, right? And now, if I click play, and all of these commands are just the same as they were before, it should bring me to exactly the same place. No, dataset in memory has changed since last save. That's okay. That's okay. If I were confused and didn't know what to do with that, I would take this, copy paste it, and throw it into Google with Stata at the end. I'm just going to promise the students at this point, if I go to help use, there is an option called clear. Now, when it's in these square brackets like this, obviously it's optional. The square brackets mean optional options, whereas we remember that the curly brackets from dstring and toString had curly brackets, which meant you had to have at least one of the options, right? One of the options is called clear. It's super useful. And the super, super useful ones, it will actually just give you straight up at the top most of the time, which is super nice. Clear specifies that it is okay to replace the data in memory, even though the current data have not been saved to any file. Super nice, super good for a do file. And then, of course, we're going to remind you that Stata is your friendly assistant. Stata is not going to delete your data out of your data set. It doesn't want to get rid of number and yeet and all of the changes that you've made unless you explicitly tell it it is okay to do so, and we are going to do that by specifying the clear option here in our data set. Now, this should run, boom. Look at that. Number is only with the values that were under 10 now. Super nice. And then I go, oh, wait a second. I actually wanted the ones where number was exactly equal to 10. Let me just rerun that. Oh, look, there weren't any. Then I go, wait, were there really not any, or did I type something wrong? Well, the nice thing I can do is I can actually just highlight part of my do file and just click run when I've got it highlighted, and it will only do those that I've highlighted, which is super nice because now I can look over back at number and say, oh yeah, none of them were actually equal to 10. But I do want to keep the ones that are equal to, I don't have any duplicates, do I? That's a shame. What can you do? Maybe I want to keep the ones that are missing number, right? And so I'll run the whole do file again and boom, look at that. Amazing. Let's bring it back to the less than 10 thing that I had before. And look, this is your undo button is what I would tell to the students, right? Like this is your undo button. You have to keep careful track of your code, right? Like, so what you do is you come to the command window, you open up your data, you look at it in the browse window, and you run a command. And you look at your browse window, and if it does what you wanted it to do, you take that command and you put it in a do file, which means you're keeping track of exactly what works and exactly what does what you want it to do, and you put that in the do file. And then that way you can redo the stuff super easy with just a click of the button. And once we've gotten over that, right, running the whole file versus running part of it, treating a do file as an undo button, I will stress what I, in my opinion, think is one of the most important things that you can do when you are writing a do file, which is to comment your code. And when I first taught this, I actually brought up an example of someone who had sent me some code for a related thing, and I had looked at the code and said, this is awful, and nobody commented it. I would recommend not doing that with any de-anonymized examples because it was a little bit awkward because I ended up working with the person whose data I had shown, and they were like, oh yeah, normally I comment, but I didn't think the professor wanted me to. It was a whole thing. I would just recommend stressing as much as you can without without referring to any specific examples other than yourself, which is always an example that's free to use, right? So what I would actually do to stress this is I would go back and I would say, okay, so the first thing that we need to do, first thing I want to do is I like to give myself some space at the do file, right? Maybe you don't, but that's okay. And I'll introduce that this asterisk here makes the whole line a comment, and the comments are green. If I were to, and then I'll like type a comment, run a command, and I'll show them, hey, it will ignore the comments. It won't actually try to run anything, so you just use it to talk to the people who are looking at the do file. Maybe you can talk about work examples where you had to collaborate with a co-author that was particularly bad at commenting their code and how much time you could have saved if maybe they had just commented it or something to that effect, right? But commenting code is so important, so please stress it to these students. Even if, and it's just a good idea in general in life, if you can make life easier for people who have to work with you later or for yourself when you don't even remember what you were doing when you wrote it, like just think of people that you're collaborating with, even if that person is just you in the future, and if you can make their life easier, you should do it. That's just generally, it's just generally a good idea. So the first thing I would do is I'll take the first command that I wanted, which was that cd command, bring it from the history, come over here, copy paste it. I'm going to put it in the do file, but right up above it, I'm going to say change directory to where the example file is, right? So that I remember, oh, why did I run that command? Because we remember from the start of the lecture, and this is also a nice time because we get to go back and review everything that we've done in the lecture, which is super nice. Because at the start of the lecture, we realized that Stata was looking in the wrong place, and so we needed to tell it where to look for this example file that we wanted to use. And then we get to pull up the use file from before, right? And we'll paste it in here, and then we'll say, open the example file, or whatever file that we wanted to use, right? And then we're also going to put even if there's already data in Stata or something like that, and so we'll have the clear option, right? And the nice thing is once you get really good, your comments don't have to be so dry, like you don't have to specify this is what the clear option does all the time if it's like super obvious, which clear on a use command is super obvious, right? And they'll get that with experience. But right now, while they don't know so much about Stata, this is actually a super helpful thing because it just continually reminds them what is my line of code doing. Let the comment tell you exactly what the code that you're writing is doing, so that if the code that you're writing doesn't work or you pull it and something is different, you know what you're trying to do, so you know how to like Google how to do it or go into the help file and do it, right? So just keep that in mind, right? Or stress that to the students. If you're watching this in the record linking lab, this is a direct call out for you. Please do this, okay? The command that we kept after that was we renamed string to yeet. This one is pretty much, this is one of those commands where like you don't really have to leave much of a comment, but just it's nice. So just do it. Rename a variable for convenience, right? Why did you do this, right? Let your comments remind you if it's a decision that you made for some reason and it seems like a weird, because like we didn't have to rename this from string to yeet, but we did it because it was convenient, right? Or for fun. So maybe just, if it's a strange decision, just write down why you did it, so that later people can come back and go, oh, that's why this is called yeet and not string. That's weird, but whatever. We'll take it, right? And then we wanted that, I think earlier we had, what was it, we wanted drop if number is missing, right? So let's do drop if number is missing. And the comment that I would have written for that one is like, the observations that don't have number are useless for this project, or something like that. Why did you make that decision? Well, it's because these observations are pretty useless, right? And then we wanted to, of course, keep if number is greater than 10. That was the other command, right? So write that in here. We're looking at the ones with number, right? Whatever that is, like an ID lower than 10. And then I rerun this whole file. And I notice it didn't try to run any of these comments or anything. Like it didn't try to run the command the, which is super nice. And then I realized that, oh, look, I actually made an error because I wrote this comment ideally before I wrote this line of code, if I'm doing an assignment in this class, right? We're looking at the ones with number lower than 10, but I realized, oh, I typed that backwards. Let me just go fix that really quick, rerun the do file, and we're back. And then basically, I just show them how to save a do file. And at this point, I don't think they actually need to save any file. Well, what they'll do is in the assignment that I've written, they will modify the save command to save a comma-separated values file. So right now, you don't actually have to show them how to save an actual data set, but you will need to show them how to save a do file. Because with the resources that I have linked in the description, there is a do file that you'll take all of the students' do files, have them upload those to wherever they turn in their homework. You download those into a folder as a batch, and then all the instructions are in there, but basically you'll run a file that will grade all of them for you, which is super nice. Well, it won't like grade all of them for you, but it will let you go student by student and see what their answers were and then just give them points accordingly, right? And ideally, I would be able to actually give them a grade, but I like to leave that up for discretion a lot of the time. So I would say, here we go. We have this do file. There's an asterisk here, which means it's not saved. So I just come to the save and I'd call it, in this case, in the class that I've designed, this would be homework 11. That would be the name, and I'll save it to the desktop. And I'll save it, open the desktop file and then save it to the desktop. And then I'll point out here is the do file. And if your computer is set up to run Stata really well, you'll have these little Stata icons here. You'll notice that they look the same, except if I run a clear here and I close out of this do file, when I drag this into here, it opens the data set. That's cool. And I browse and there it is, yeehaw, right? Let's get rid of the browse window. But when I drag the do file in, it just opens up the code. And then I can, boom. And whoa, it brought in number and yeet, and if I click browse, it did everything that we saw that it was doing, which is super cool. So that is basically all of the knowledge they will need to do the first assignment. The first assignment introduces them to a couple new commands, gives them the resources that they need to figure out how to use them, has them fill in some blanks, use the browse window, all sorts of fun stuff. I encourage you to take a look at that assignment. Just for those of you who are in the record linking lab using this as like a tutorial, please do that first assignment. Just see if you can do it. And you have the resources linked to the answer keys for this assignment and stuff, and like the templates and all of that. It's on my GitHub. All of the stuff is going to be in the description, so please use it to learn. For those of you who are teaching a class using this lecture, please get familiar with that. It will, well, I mean, you don't have to use the assignments and the resources that I've linked, right? This is still a pretty basic introduction to the idea of Stata and just like the general things that it does. But I would recommend it. I think they're pretty nice, and we've had the pleasure of proofreading and adjusting them as well. So I encourage you to use them if you'd like. I don't even necessarily need you to cite me. Just knowing that someone out there is using my stuff is it's enough for me, personally. So that will be all. Again, those resources are down in the description. If you have any questions, you can go ahead and email me at labhours@teamorg.org or inquiries@teamorg.org. Probably inquiries would be best. All of that is on teamorg.org if you'd like. I don't know if you've gathered that yet, but it's nice to just have a little hub. So that will wrap that up. Hopefully you found this useful. If you'd like to teach this lecture, of course, we have the lecture notes, the assignment, all that stuff in the description. If you'd like to teach this lecture, I hope you found that this having this example is helpful. Again, you're going to want to project everything that I did up here on the screen to the students, of course. And I would also recommend, this is an important thing I forgot to mention, do not have them try to follow along with it. They will get lost, or someone will come in. This is all in the lecture notes, but someone will come in and you'll be halfway through the lecture, they won't be able to get caught up, and they'll just completely be lost. Do not try to have them follow along with this lecture. Instead, just if you have to sit them in a computer lab, fine, but this lecture is actually designed so that you don't have to have them in the computer lab. For the second Stata lecture, also don't have them follow along, but do hold it in a computer lab, because that lecture is like half the length of this one, and you want to spend the last half just helping them with individual questions that they've picked up. So all of that, of course, in the lecture notes, in the teaching notes, or whatever I called them, in the description. For those of you who are working in the record linking lab, I hope that this was helpful for you. The second one is also going to be helpful, and then I also have a separate playlist for you guys with the more niche things that you would need to do in the lab. So hopefully this was helpful for you guys. Thank you for watching. Thanks for coming into lab hours. Hopefully you'll come next time for Stata 2. That's what we'll be doing next. And thank you for watching. Have a wonderful, excellent day.